2, 1. Hello, everybody. Welcome to another virtual QASIG. I'm Jim Frazier with CoreDev, and I'll help moderate. And I just want to set up some of the housekeeping for this evening's event. Then I'll hand it over to Joe, who will introduce our speakers. While our speakers are talking, everybody will be on mute. So just be aware. Maybe jot your questions down. And at the end, if you could pose your questions via the Q&A at the bottom of your screen, I will read the questions off and make sure that we get everything answered for you, hopefully. May have an opportunity to do a hot mic or open mic at the end if anybody or everybody is interested. But primarily, we want to field those questions through the Q&A section. If you happen to put them in chat, we'll find them there too. But primarily, we're going to go for the Q&A section. So this is the QASIG. For those of you that aren't aware, we have also started a PM SIG, and it runs the opposite months for QASIG. Our next one will be on December 9th. So jot that down on your calendar, where we'll be talking about the emerging role of company ecology on project methodology. So December 9th for the QASIG, and then the following month we'll roll back into, for PMSIG, and we'll roll back into QASIG the following month. So let me hand this over to Joe Dillon, and then we'll get you started. Just remember, questions, please hold them until the end and type them into the Q&A section. Thank you very much. And Mr. Dillon, the floor.
Cool, thank you. And I'd like to welcome everyone back to the QASIG and welcome all those who are new for the first time. I miss getting together, but Zoom makes events like this possible. And this is a really interesting situation. Let me set the stage for it. Our speakers, Rob and Monica. Rob's in Montreal. It's 9 o'clock at night. Monica's in Uruguay. It's 11 o'clock at night. So this is a true international event. And so it's pretty exciting. And they're going to be speaking about teaching testing to programmers, which is something that I've always wanted to do, because at CoreDev, we always go to testing conferences, PNSQC, Star West, Star East. We've hosted the QASIG for 19 years. And it feels like in some ways, it feels like we're teaching to the choir, preaching to the choir. And I mean, yeah, we're sharing ideas and sharing innovations and things like that. But I would love to go to a development conference and be the only testing shop there and talk about some of the things that our speakers are going to be speaking about tonight. So if anybody can recommend a good dev conference, I'm open to hearing about it. I'd love to set up a booth down there. So before I hand it over to Rob and Monica, just want to thank Krista and Shelley for coordinating this event, because it's very unique, you know, with Zoom and international presences and everything. So I really hope you enjoy the talk. And so off to you, Rob and Monica.
Okay, well, so I'll just try to share my screen here. See if this actually technically works. Bear with me. Here we go.
I have. So, hey, by the way, Rob, how long have I known you? Maybe like 15 years or something?
I don't know. We did a project together starting in 2004. So I'm not going to count anymore. It's a long time.
We're in different countries, so it's not like we get together and have a Guinness every week, but I've always known you as being a great guy and always having something to offer. And this is an exciting talk. I'm looking forward to it.
Thanks. Yeah, it's been quite a while, and it's been a long relationship with you and with the testing community of the Seattle area. It's awesome to be here. Just let me know if you can see my slide there. Is that visible?
Yep.
Okay, because I'm sort of always at the behest of Zoom here. Welcome to the talk. Thank you very much for joining Monica and I. Just to quick intro. Okay, so My name is Rob Sabourin. People call me Rob Sab. I've been involved in software engineering, since the dawn of time. First code when I was 12 years old, first commercial release, 1982. I've been spending over 20 years working on the problem of teaching software testing concepts to programmers. I do this professionally and also academically. I'm an adjunct professor at Mcgill University. So that's me. Monica?
I am Monica Wodzislawski. I am from Uruguay, and I have been teaching software testing to developers for over 15 years. I'm also a professor of software engineering and testing at the Universidad of de la República in Uruguay. It's a public university. And I was working in software quality in Uruguay and other countries. I know Rob from CAST some years ago.
So we're not going to count.
Yes, no.
Okay, so just to point out an overview. So we're going to talk a little bit about the motivation for training programmers about testing. We'll talk about the wide variety of formats that we've used, both commercially and academically. We'll give some examples of what we feel does not work. That's our Teflon, and some examples of what works. Monica, anything to add in the overview?
No, as we work at the Centro de Ensayos de Software, is a software testing center, a foundation from this university, and we do testing, nothing but testing. And as testing service providers, we detected that applications of poor quality distracted us from finding the most subtle and severe bugs. And also that there is still a lack of knowledge about the wide range of testing activities. So we decided to teach testing to developers as a contribution to software quality.
There you go. Now, all right, so why? The motivations. Well, I've seen a lot of different motivations. Three basic areas. The first one I think is a strong motivation is business. Companies want to make more profit, lower costs, have the developers focus on doing new development, not fixing old problems. And the idea would be if we can get programmers to know more about testing, that maybe they'll be able to have less rework in the code. So there's a business motivation there. That's a cost motivation. There's also a professional motivation to look at programmers and say, hey, if programmers can make and keep commitments and develop really high quality code quickly, they'll be stronger, they'll have a better reputation, they'll have more marketable skills. So it's basically improving the skills of the developer so that you can have better opportunities, better career opportunities, better career growth. And the third motivation that I see, and I see it among my customers, but also people who try to train programmers about it, I consider it a weak motivation, and it's tool-centric, where they try to basically say, hey, let's teach the programmer how to use this test harness. Let's teach the programmer how to use this mocking tool. Let's teach the programmer how to use this dashboard or coverage tool. And yes, this is important to learn these tools, but learning these tools does not teach testing to a programmer. And just this week, Monica, it happened to me where I had a project at Mcgill, and the students took, instead of doing the test design, they took a tool that's basically a commercial tool, and the tool promised to do testing of REST APIs, and all it did was check the HTTP error codes, and it didn't look at all about did the functionality work. And that's what the vendors today in the tool world are teaching as testing technique, which is not testing, it's how to use the tool. Granted, you need to learn how to use tools. I'm not against learning how to use tools, but there's a lot more to testing than that. Monica.
Yes, no, that last but not least, we have to promote professional responsibility and ethics.
There you go.
Yes, programmers ethics and professional ethics and ours as a teacher, as teachers.
There you go. So this is very important. I think that's something that some people leave off the shelf. There's process motivations. So sometimes we need to sort of show people how to do collaborative development. I have audited so many courses today, especially ones that teach teamwork for agile teams, and they're very, very focused on how human factors and soft skills help people to collaborate on teams. But darn it, collaborating is more than just that. There's actually what I've come to call technical skills that really matter. And these technical skills to do it are things like troubleshooting and debugging and bug isolation in the IDE, not independent of the IDE. And this is something that's collaborative. So I think if we knew how to do that better, we'd have better quality software, faster, less rework. There's other process motivations like introducing concepts like the double Ds, ADD, TDD, BDD, DDD, DDD. It's all about driven development, test-driven development stuff. Okay, well, you better know about testing before you start driving your development by it. Even if it's a programming approach, it needs strong test design skills to leverage and to use it. And then there's this sort of big thing about process motivation, like shifting everybody left and whole team quality issues. Well, if there's whole team quality issues, maybe there should be whole team understanding of how to assert that we have quality or to validate or somehow confirm it. Monica.
Yes, that we feel that there are many courses and coaching on agile methodologies, but very few cover the importance of software testing to succeed. And this shift left testing requires strong testing skills. And we can shifting left as far as including clients and users, as the DDs suggest. But we need testing skills. So we have to teach them.
Or somehow they must be learned.
Yes, somehow.
Unfortunately, learning the hard way sometimes.
Yes.
So how do you do that, right? And let's look a little bit at formats here. As the formats almost, it could be a comedy. We could make a comedy movie about formats for trying to teach developers about testing. My favorite starting point was a security company I worked for. Very, very long time ago, they hired me and said, Rob, help teach our developers to design good tests. And I said, well, okay, here's some methods. And then they said, no. We want you to talk to them for one morning, 200 people at the same time, and just show them everything. And then let them walk away and they'll know how to do it. And I said, well, not really. They're good. I'm going to scare half of them away, and the other half aren't going to know how to apply it. But the Big Bang idea was basically sort of, can you give an overview? And what I did when I did that was I actually created a one-page checklist of unit test ideas, and I sort of tried to use the 3 hours to teach them how to use the checklist. And that was, for me, a good starting point, because then at least they knew the breadth of the problem. So that's one format that I've used. We've done group activities like a small group public, where everybody comes from different companies to learn test design for programmers. We've done on-site versions of it, which is more specific, usually tied to an application. Done methods that are agile-ish, like, for example, dive in and work with the whole Scrum team. And that's been pretty effective. Also worked in things that are metaphors like dojos from the martial arts, if you've ever looked at that style of instruction. These are all different formats, and some of them have been less effective than others. I believe that when we can get the whole team involved in the process of learning, then they can see how the skills apply. But different strokes for different folks. Some people want you in there for just a very short amount of time. Monica.
Yes, I would like to speak about our testing for developers because we prepared this course in 2009, and
Mhm.
it was a presential course, so we were there 24 hours course, and we tried to permeate the development process activities with testing insights, strategies, and tools. So it contains not only techniques but testing culture elements.
Mhm.
For example, it includes quality goals, risk analysis, testability, post-analysis of bugs, and different types of testing, unit integration, and end-to-end testing, manual or automated. And now this course, we have an online issue of course, instance of course, and we experiment now that in many companies they want this course, not a testing course, but testing for developers course.
Now,
And
just to
yes,
comment, the outlines of all these, the topical outlines of all the courses we're mentioning appear in the paper, which we're sharing with anybody who wants it. So I hope the
yes,
people who are running the QASIG make that available to everybody. And we have details that for each of the courses we're talking about. There's actually like subjects, what's covered, what's in it, and what's the sort of approach we're using to teach it. Sorry, Monica, I didn't want to cut you off.
no, perfect, perfect, yes.
All right, so moving along, click. to the-
Yes. No, the agile methodologies. Perhaps you want to speak about your courses.
Not particularly. I'm actually having technical difficulties here with my screen share.
Yeah,
Believe it or not. I
I
can't.
would like to speak about to tell something about the testing in agile methodologies course. Yes, I see you have problem.
Yeah, sorry about this, but something happened, and uh, for some reason, PowerPoint has gone into a weird state here.
Yeah.
There, it's coming up. Something very strange is that.
Yes. Here you have the.
Is it visible now
Yes,
on
but
slide?
you are at the academic courses in the
Okay, so
other.
I'll just try to go back. Now it's academic.
Yes.
Sorry about this technical glitch. Sorry, go ahead, Monica. I didn't want to cut you off.
No,
Back
no.
to
So this course, testing in agile methodologies, I like this course because it's an agnostic course. That is, it is completely independent of agile methodology flavors and software tools. And I like it because it is a thread connecting the history of software engineering with current demands. So how it articulates that
It-
is not something that spontaneously appear in the horizon,
well,
the agile methodologies.
it's very interesting because if you look at your, for example, the pointy-haired Dilbert boss who's managing your team, they probably learned about testing back in the days when black box testing was a dominant approach that was advocated by people like Boris Beiser. And today, of course, we know that that's one of many different perspectives to use. And back then, they looked at testing as objective and had to be done by independent teams and all this stuff. And for today, we look
Yes,
at it codependent and done by collaborative teams. So it's very different models. And certainly, it's very important to show people how testing fits into these agile methodologies. So it's an awesome way to sort of look at testing. Where does it fit in to the process models?
yes,
So I'm going to try to advance the next slide here, if I can succeed in
yes.
that. Hello, slide.
Hello.
My slide is not moving again. This is a technical snag here. Now it's moved?
Yeah, here
Okay.
it is.
Now it's gone again. Unbelievable.
Do you want me to?
I got
Yeah.
it. I think I
Yeah.
got it. So this is academic. So both Monica and I, we're professors at the academic level as well. And I basically work on testing courses that are part of a software engineering program, indeed, that are mandatory courses. So everyone has to take and pass these courses before they get their degree in software engineering from, at least where I work, at Mcgill University. And there's a few different approaches that we've used and we use. One is case-based, case study-based, where we really dive very, very deep into a very beautiful and real case studies. So we have a case study-based approach. Another one is basically custom courses that are made for specific people, like I did for UC Berkeley, custom training for developers of Internet of Things applications. So that's just tied to a sort of a very specific technical market. But otherwise, we cover a lot of different grounds. In the current undergraduate offerings, we basically cover testing from the point of view of test design, risk assessment, test planning, non-functional and functional testing. And we do projects which involve a lot of automation, but what we're doing this year is we're doing exploratory testing with automated tools. So we're basically doing what almost you'd call automated test and exploratory testing together. Because I want to just break the myth that those separate things, automated testing can be done with exploratory fashion and vice versa. Exploratory testing can be done with tools. So we mix the two, and we have a big project applying things. And we also use this year flipped learning. So basically all of the lectures are videos and articles that the students read before the class. Then in the class, it's 100% exercises and case studies. That's it, that's all. And that seems to be quite good, although we got to wait till afterwards to get some feedback. That's currently what we're working on right now. Monica, you have some innovative stuff that you're doing.
Yes, we have two things to remark. The first, that we succeeded in including explicit testing activities in several undergraduate programming courses. Programming 1, programming 2, so on. And students were encouraged to bring their own test cases and to share the test cases, not the program, of course, not the code. The slogan was post your test case, build quality collectively. It was very successful. They engaged in the play.
Now, you also had a dedicated performance testing course?
Yes, but yes, this is not undergraduate, but postgraduate. And we have a software testing workshop. This is an elective course, undergraduate course, an elective course, but the vast majority of students are already working as programmers and choose these workshops to complement their testing knowledge. And the workshop includes functional testing, testing automation, performance testing with a theoretical and practical approach. And what is rewarding to mention that several workshop students become so interested in software testing and quality that they have picked this subject for their degree thesis. That it was unexpected for me. So and this performance course, this is a postgraduate course, and it's very interesting because the attendees are very heterogeneous, but they learn the need to run performance tests. Secondly, incorporate the related concepts and methodologies, delve into performance testing strategies and techniques, apply different tools, and also learn to manage performance testing projects, a methodology, and how to manage them.
It's interesting. I just this week audited a major curriculum of teaching testing to people in the UK for programmers, and performance testing did not even show up in the curriculum at all.
Yes.
And of course, it's so critical to make sure that people are aware. And that involves a lot of teaching because there's the modeling and the analysis, not just using the tool to run the test. There's a lot.
No.
The modeling side of it.
Yes.
Now we get into the Teflon. Teflon, Monica?
No, Teflon is yours.
Okay, I'll do the Teflon. It's mine. I'll tell you
Do
everything.
the cakes with the syrup.
First of all, Teflon, we're saying things that we've tried that just, it doesn't work. It's painful. If you have a group of people at a public class and everybody has a different technology stack, it's a distraction. It defocuses people. You're going to spend your life hobbling between what's slightly different between this IDE and that IDE and this programming language and that programming language. It's basically very difficult. And unfortunately, people who are good, strong programmers really know their IDEs. And if you're an instructor and everybody in the room, if there's 10 different IDEs, you're going to be looking at questions that are very detailed about things that you might not have that detailed knowledge of. And that's just a distractor. So it's to balance the field. I try to keep people with a similar technology stack, but still this is Teflon. Second one, if everybody's got a different SDLC, a software development lifecycle model, it's going to be confusing. How we do just development is different. Forget about testing and development and programmers. What is in scope? What is not in scope? What is a requirement? All these things would be dramatically different. So it's important to avoid too much diversity in SDLC. And it's funny because I love to teach groups that have diversity. And a lot of the conference work I do and teaching testing design techniques I do, I love a diverse crowd. But I found when teaching testing to programmers, the diversity distracts from the learning. Second thing, I am a huge fan of paper and pencil exercises. I've been doing that since kindergarten. I love it. And I was even reviewing, I've got a collection of paper and pencil exercises from my dad in the 1930s. And I love paper and pencil exercises. You can learn so much by drawing sketches and organizing things. But I find teaching programmers about test design with paper and pencil exercises just doesn't stick. Sure, they'll do it, but they're going to get bored of it. And that's my experience. They get bored of it. They want to code. They don't want to do paper and pencil exercises. So you got to be careful because a lot of the test design training material people have start with, hey, let's do boundary test analysis. Let's do exploratory, let's do equivalence classes. Let's do decision tables. All this is paper and pencil. And the programmers, I want to write a bunch of code. You know, that's nice that you can do that on paper. Let's write some code. Another thing is trivial exercises. I found that although I like to start with trivial to explain concepts and work my way up, I find that a lot of programmers, delegates at training courses that are trying to teach test design to programmers have trouble seeing how the trivial example relates to their complex code and therefore just ignore it. Instead of trying to figure out how it fits, they sort of say, well, that technique doesn't apply to us, or that's too trivial for us. We have a much more complicated problem. And I found this is really big Teflon. That so like trivial exercises, tricky business. We'll explain in the Velcro part how we could maybe avoid that. And then timing of exercises. I saw this in Texas. I was working with a bunch of people, programmers taking testing exercises, writing code, get competitive. And they're trying to out-program each other. And I had exercises I thought would take 20 minutes or a half hour. We're taking some of them 3 minutes and some of them 20 minutes. And what do you do with the gaps? What do you do with the holes in between? So it's very awkward when some of the delegates really finish something very quickly and other ones take longer to do it. And this I don't see so much in training, except when I'm working with groups of programmers. And programmers, I don't know if it's all programmers, the ones I work with at Mcgill, I have in my classes here, I have 160 programmers. They're all superstars. And boy, they get competitive. I mean, it's crazy to watch. And so what do you do if there's a bunch of people that are going slow and faster people at the same time? And this creates a little bit of a problem. It's awkward.
You need continuous exercising, Rob.
Yeah.
You need continuous exercising,
Yeah,
continuous testing, continuous exercising, continuous integration, continue.
There you go. All exercise all the time. Never stop. Have a whole bunch of them.
Yes.
Let's see, other Teflon things that really tricky coverage models. Coverage models. There's basically a lot of things that people try to simplify and trivialize. There's over 100 different coverage models. Coverage models like code coverage teach you that it's important to test the code you wrote, but how do you test the code you forgot to write? Almost every bug I've seen in commercial software engineering, when interviewing the programmer about what they fixed, they said, well, they had to add code to handle a condition that wasn't handled. They had to add code that wasn't there. Coverage models don't tell you anything about bugs in the code that's not there. They only tell you about problems in the code that's there. This is a huge problem. I think tool-specific training is too vendor specific, and so you get attached to a vendor. Sure, you need that sometimes, but that's not. I don't think that's going to stick. And it's certainly no one vendor will teach you how to apply the technique to other vendors' tools. Not that I've ever seen. And believe me, I've taken a lot of vendor-specific courses, and I'm not saying the vendor courses are bad. They will teach you what they want, what you're trying to learn, but not how to generally apply the stuff.
Yeah.
Other things, templates are very SDLC specific and basically encourage people to become zombies and rather than thinkers, right, Monica? The cognitive versus repetitive models.
Yes.
So if you go there and you say, hey, developers, I'm going to teach you a bunch of templates, well, that's not really going to help anybody. And a lot of developers don't have much patience for that, although they like patterns. We'll get to that later. Code-centric focuses. Not all testing is designed by writing code or by using libraries. Just because Python has a nice library doesn't mean that absolves you from test design. And then we have a regression automation focus, where everything is about checking to make sure we didn't inject a regression bug, checking like dashboards to say what passed and all this stuff. And of course, that to me is a big distraction. You could spend 2 or 3 days teaching people about how to make a nice dashboard and not teach them anything about testing. Monica.
Yes, no, I agree with this, with most of them, but this tool specific is the very dangerous, because it's very dangerous because tools are not here after a few years, or they are so difficult after to use that they stay at the shelf, and the frustration the frustration make them say that testing is not useful, or automation is not useful, because they couldn't use the tool.
Your favorite part, of course, is the Velcro, right, Monica?
Yes. Yes.
You want to start?
Eh?
You want to start?
Yes. If you want me to start, that
Go ahead. I'd like you to start with your risk model stuff.
Yeah. No, that. Hello?
Yep. Hello. Can you hear me?
Yes, yes. That it's very important for us to set quality goals, and to analyze the code before, and to analyze before coding, and to identify these objective goals will help to identify risks and to mitigate risk, both when you are coding, programming, or after with the testing. So this risk analysis is the guide to both coding and testing. So it's very, very important, and it stay. The students, programmers understand the importance of this risk
Uh,
analysis.
and related
Risk
to that,
analysis.
a mechanism that I like to use is to brainstorm test ideas as a sort of a team activity before you start implementing a requirement or a story, to work with your team to brainstorm test ideas. And these ideas, you're not saying they're all going to be necessarily done by the programmer, but it gives you a sort of picture of the scope. So you start with the risk, understand the risk assessment, the benefit and consequence, likelihood of failure, business importance. Then you jump into test ideas, brainstorming them as a team, and identifying them so that
Yes.
you can choose the best ones. And I'm not saying brainstorm to get a list that's impossible. Brainstorm to come up with a big set so you can choose the best of a set. Because you never have time to test everything, so why not get a rich set? And I find that brainstorming stuff really sticks. It really, really sticks. And it's actually beautiful. And it's a habit. My recommendation is almost always in an Agile team, before you start implementing a story, to basically invest maybe 15 minutes just brainstorming with a few people in the team, test ideas related to that story. And it's fantastic.
Yes.
How that's thing, and what is the type of data you're going to use, and what is the type of techniques you're going to apply. So I think that's a Velcro. Programming exercises, right? You were saying continuous exercises, have them build on each other.
Yes. And we encourage people to study the bugs that escape into production.
Excellent. Yes.
Yes, because you can work both with the errors students make frequently and the tests that there were not written to detect those bugs. At the end, the students, at the end of the course, the students prepare an improvement plan for each person to check their programs and their codes, and for the organization to work better with these bugs, to analyze these bugs. Because in many organizations, the testing bugs are in one tool, but the production bugs are in another tool, and they don't make the cross analysis.
I think there's one other point related to that, is that, and this is right to your point, it's important to show how fundamental techniques, when you're training the programmers about testing, how do the fundamental techniques apply to relevant problems that matter? And
Yes.
the best ones are looking at production bug escapes. How could we have avoided this bug escape? And what test design technique or test approach would have found that bug before you checked in your code? And this to me really sticks when you show it with real bugs that really went to production with relevant techniques applied to relevant problems.
Yes.
That sticks. Just the techniques by themselves, it's interesting, it's academic, but I don't think it's going to stick unless you tie it, as Monica's saying, to study stuff like production bugs and how we can avoid them. Which is, by the way, Deming 101, if you're interested in the quality theory.
Introduction too.
There you go. Now let me see if I can figure out how to get to the next. It worked. I'm always shocked to work here. So more Velcro, why not, right? You said quality goals already?
I said something, yes, that the quality goals, but I didn't say that they are many to use the most appropriate standards or guides on the context. For example, if the quality goal is security, you have there the OWASP stuff to work before you code. Or the W3C for mobile accessibility, or the other for the web accessibility, W2 something that I don't remember now. But you have...
Yeah, you want to find the right model for the quality factor that matters.
Yes, if you can use it, invest in studying before you build the software, not after, to
As
prevent problems.
yeah, as George Box, the famous statistician, said, all models are wrong, but some models are useful. And
Yes,
I think that what we want to do is in this, I think, is real Velcro. Teach people how to create conceptual models that might be imperfect, but that help us to assess quality of a system, help us learn about the system. And as we learn about the real behavior system, we can improve and adapt our models. So the models get better and better. And I think teaching people how to make conceptual models of systems and then design tests to confirm or refute the hypothesis that that model is valid is a very, very scientific approach, a very problem-solving approach, and something that I think sticks.
yes.
Patterns?
And yes, patterns and anti-patterns. So in our experience, it's very important, essential to teach patterns and anti-patterns for developers. Also, to learn good practices, especially for testing automation and performance problem recognition. Because
Uh,
in both we need it's very important to teach patterns, and it's not frequent to
on
teach
the
this.
on the well, there's also some beautiful books like Dorothy Graham's new book, A Journey Through Test Automation Patterns,
Yes,
shows a lot of the applicability of that sort of thinking. And that we've definitely both seen that really help and really sticks. I'm a big advocate, of the detailed case studies, where in the case study, I want to show how patterns can be applied to real problems. And that's done. I like to do that with detailed case studies, not just vague, white boxed, like marketing sort of case studies, but really deep, dirty, detailed case studies. By the way, I've done 2 case studies about projects I've done with the very beautiful consultancy in Seattle called CoreDev. Thank you very much over the years. Very important. I still use them in training. And the last one related to case studies, of course, and field reported bugs are taxonomies, right? Examples of common faults and solutions.
so
There's a
yes,
beautiful thing that I've seen. Boris Beiser spent his career studying bugs from the point of view of what programmers did to fix them. And I reviewed that with a guy called Otto Winter in Europe 10 years after Beiser retired from this. And I found out that he only added a few new bugs to the list after interviewing even hundreds more programmers. And the fact was that his comment was that developers had perfected screwing up code. And it's true. There's the bugs that are injected today are very similar to the bugs that were injected 20 years ago. If we
yes,
can teach people common faults and solutions, we can actually improve coding. And
yes,
there's very few new types of how can I put it, faults injected by programmers. The similar faults are injected, maybe in new languages, and maybe they have different defects in the end, but the faults,
conceptually are the same.
there you go.
Yeah,
The more we advance, the more we regress, right?
yes.
So those are just some, and our article goes into more detail about all the Velcro and all the Teflon. We have a paper, right, which is available, some contact information for Monica and I. We love to help build community. And I want to just sort of say that I don't have any major concluding remarks. I think that some of the stuff we're doing now is really exciting at both in Uruguay with Monica's work and my work in Montreal. And I think that there's more to come. I think there's some really cool techniques that are getting there. And it's just more and more important to sort of look at how to teach programmers about all sorts of concepts of testing. Monica?
Yes, that as a final remark, I would like to say that we enjoyed writing this article and sharing our experiences in this somewhat underrated topic, because they don't uh, speak about teaching about testing for programmers, and we feel that technical skills, I don't want to say hard skills, but technical skills and technical collaboration, as Rob used to say, are essential for building and testing quality software. And also that the problems are very similar, even though we live in and work in quite different contexts, and are similar over the time also, over time also.
So then,
And I would like to thank you for your invitation to participate in this important meeting.
yeah, thanks for having us, for sure. Thanks. So that's the slide talk part of the show. Love to hear Q&A and any comments from the audience.
Well, if you look at the bottoms or the bottom of your screens, just down there, there is a Q&A section. So please feel free to type in your questions there, and I will relay them if and possibly go to open mic if needed, or depending on how much we have or how many we have. Our first one comes in from Terrence Kennedy, and Terrence is a contractor in a large organization with different entities having different approaches and outlooks on automation as it relates to mobile testing. And the question is, what advice would you give to an individual or organization to solidify and unite behind one framework or technology when everyone's fighting for their own frameworks and processes?
Well, you probably get different answers from Monica and I. Monica, did you want to comment on that first?
No, I didn't know. I didn't pay that attention.
Let me put it this way. In my experience, there's two ways to look at this. One way is to say that the developers are wise and right to fight for their independent frameworks. And I think of them as mechanics working on Ferraris. And they're not Chevy mechanics, they're Ferrari mechanics. And each one has their own tools that they've mastered and they're good at, and they are just able to fly with the tools that they bring with them. So one approach is to let the developers choose the right tool, let the punishment fit the crime, choose the tool to solve the problem, but have a method they've got to fit within. For example, if you're doing automated frameworks for story testing, maybe you want to construct the story tests in a consistent way, maybe using some modeling approach based on Gherkin or something. Well, I'm not trying to push one model or another, but do a model framework which is common, and then let people implement it in a way that just makes sense in their technology stack. I think that there's certain things that don't make sense to standardize across a whole organization. Now, let's say you want the opposite problem, and you want to be the Chevy mechanic, and every project is the same, and you want to bid on things and reduce licensing costs for tools and all that stuff. Well, then you've got to staff it with the right type of people, and you're not going to have the same type of engineers as those Ferrari mechanics. You're going to have people who are good, competent people, but you're going to hire them because they are good at repairing Chevys, and they've been repairing Chevys since 1953, and they know how to do it. So you'll have a different type of team, and it's when you have the superstar independent team with an organization that's trying to standardize things, that you have a conflict, and that conflict might not be healthy. So I would say there's two approaches. One is if the developers really want to go with a certain type of tool set, don't stop them. Just figure out a way to sort of make, as Monica was saying, patterns maybe that are going to be consistent. And don't forget tool agnostic. I mean, I've been at this so long. Every time I start a new project, I'm using a different tool and do a different compiler, different CPU, different technology stack. I don't like to get attached to a technology stack. It's going to be different in 5 years anyhow.
Yes.
Does that answer the question? I don't know. I get excited about the subject.
And does anyone else have questions? And either in the Q&A section and or the chat. And Terrence does confirm that did answer the questions. Thank you very much.
Thank you. quiet group, eh?
You must have answered all the questions, guys.
I think there's another question that popped up
Okay.
from Terrence.
I'm not seeing it. So if you have them now, great, we'll try to answer them. If you can think of questions that come up after the fact, you're also welcome to email those in. Oh, here's another one.
That's a good question. I want that question.
Okay, go for it. Just feel it, Rob.
So could I demonstrate the exploratory automation mentioned? I'm honored. I'm so happy that that came up because that's a question I was going to ask you guys to ask me. So, yes, we just put this together, and it's really cool. It's a project at Mcgill. I don't have the results to share yet. We're going to have them to share results, videos, code, everything, but it's going to be after December. So this year it's going to go. And for the students, I also got to get permissions to share because it is academic work that's used for real. So we're going to obfuscate a couple of the examples, and they're beautiful so far. But I can share with you right now the actual statement of work, which I've shared with companies already among my customers, and they're just flipping out. They're saying, wow, if you can get students to do this project in 3 months, I want to hire them. And it's beautiful. So I will be glad to share the project description now. So if I can share that, how do I share that, Joe or Shelly? I don't know how to do it. I'll give you a copy, or you can email me, but I'm glad to share it with everybody. But we'll have the actual results, and we're going to share as many examples as we can. So I'll make it available to you. You know my contact information, robsab@gmail.com, but we will share it, and it's really beautiful. It's gorgeous. We're using JUnit, by the way, or any technology unit framework, and we're using all sorts of simple methods, like, for example, curl to do the exploratory testing. And we've got the session notes and all the artifacts, so it's beautiful. But that's a work in progress. We're doing it now. So I can also share how we grade it, which is awesome.
I would like to.
Go ahead.
No, the other question. Do you find it necessary to explain, Jim? You will read
Harry.
it?
Yes, do you
Yes,
find it
Harry.
necessary to explain to programmers that they don't understand testing?
No, I don't think so. That it's necessary to explain that they don't understand testing, but to explain the good things that they can do with testing. So the good things they can do to be sure or more sure that the software they code is quality software. And because if you begin to say that they don't understand testing, they will say you that you don't understand programming, perhaps.
Right.
So oh, always with the positive things, no?
Yeah.
To show that if they do this and that, the code will be much better.
Just to compliment that, first of all, it's an honor to have, if that's the Harry Robinson, it's great to hear from you. I do run into the snag sometimes where there's a real bias as to what testing is in someone, and to unlock that is challenging. With small
Yes.
groups, it's easier maybe than with the big groups, like the 200-person class at Mcgill is hard. But I do find that if I decouple things and I sort of talk about like oracles and test assessment, assessing correctness, separating that from the design of the problem, and sort of trying to show them that there's sort of elements to it that are not just sort of running a unit test from a JUnit and running a search from a library, and there's more to it. There's a cognitive element to it. I have specific examples. I don't have a general case. I do run into it though. I mean, I think I ran into it a couple times this week among my students where they have a real bias, And you got to break that bias. And sometimes I break it by like failing them on an assignment. And then they come to me and they said, hey, I worked hard. I said, yeah, but you worked wrong. What you did was not testing. You just basically spit out a bunch of error codes from a tool that you got, open source tool you downloaded. That's not testing. Where's the cognitive process? Where did you try to, really show that the application sort of did something useful and didn't do something destructive otherwise? So it's sort of a lot of the show them that testing is more than just checking. It's exploratory, and like the beautiful articles that Harry's written on the subject over the years, comparing Lewis and Clark's expedition with testing. It's exploratory, it's rich, and I find I do have to show people that testing is not just checking a thing. It's a broad thing, and I do run into
cognitive,
yeah.
no?
And in an academic course, I can do things like fail someone. In a public course, it's tricky. I've done on-site stuff too. Some programmers are very stubborn. They have a model and that's it. And if you say what's not in the model, it doesn't stick, right?
And
So it's a
I
tough
think,
question.
yes, I think when programmers realize the mistake they make, it's they understand the need of testing.
Cool. Thank you.
Thank you
Yep.
very much.
Well, as we're waiting for any others to come in, just a reminder that this presentation and all of the presentations for that matter are recorded and they are on our site. So if you'd like to go back and look at any of those, you're more than welcome to do so. And another reminder that the alternate to the QASIG, the PMSIG, is coming up on December 9th of next month. So mark your calendars for that one. Oh, Shelley's reminding, oh, there she goes. It's at the QASIG site for information and links to the recordings. And if we don't have any other questions, which I don't see up there, I will thank you guys and hand it over to Joe for a wrap up.
Just thank you to our speakers. Thank you so much, Rob and Monica. And by the way, Monica, happy Thursday.
Thank you. Thank you very much. Yes.
So thanks everyone for joining everyone. And it just is such a wonderful community and a privilege to be a part of it for me. And thank you, and hopefully get a chance to do it again soon.
Yeah.
Thanks again, Rob.
Thank you.
Yes, thanks,
Bye.
everybody. Have a great night.
All
Bye,
right.
everybody.
Bye.